Hello everybody and welcome back to Juno New Origins, where I was thinking that perhaps we should target a slightly higher orbit, so we have a little bit more burn time to get this thing into orbit. So that is, I think, probably the way to go. So let's put this out on the DSC launch pad for right now. We just need to get a reasonably efficient ascent profile, right? So that is the goal for right now. I want to put this thing over at 60 degrees, and we need to line this up. Right, this is actually going to be launching at night, so we need this to be at 120 degrees. There we go. And we're going to be launching purely vertically for now. Let's just get lined up here. There we go. And let's warp forward here. Okay, now we know that the quick save didn't work, but I don't want to have to do this warp a million times. So what I'm going to do right now is I'm just going to save and exit. Then we're going to resume that flight. And in theory, everything should be connected, and it's broken. Why is it doing this? Why does everything disconnect when we save this? That's bizarre. I would really like to not have to do that warping every time. But when we load this craft, it just falls apart. I don't know why. We'll just undo and exit. And then I'm going to recover the craft without loading it like that. Okay, now, did that update the time? That might have updated the time, though. Yes. Beautiful. Okay, so that actually kind of worked in a weird sort of way. Let's go ahead and launch this. And this is in this launch mode. Right, we were actually talking about changing this around so that we're firing all of these engines at once. So let's try that. I can't remember if we actually tried that previously, but I know I had mentioned it. So that's just that. Okay, now let's put this out on the pad. We don't need to warp because we should be in a somewhat reasonable position for that. And 120, there we go. Right. The interstages. I didn't move the interstages. That's my own fault. Okay, so now what we need to do is we need to add a stage, and that stage is going to be here. The interstages are going to be there. There we go. Now we should be ready to launch this thing. The main concern that I have is that our thrust to weight may end up being too high. And we'll find out. Okay, so let's go ahead and have this be filling. These exterior tanks are going to be draining like so. Throttle up, and off we go. So our thrust to weight is starting off pretty high here. I'm going to go pretty vertical here because I have concerns about not having a fairing on this. But I would prefer to not add a fairing because that's even more mass than what we already have, right? So that is definitely a concern. How are we doing on our SRB fuel? 35%. Okay. So we're going to be done with the SRB very soon. I'm just going to keep going straight up with the SRB for right now. So 6, 5, 4, 3, 2, 1, 0. SRBs detach. Now I'm going to take us over to a 45-degree pitch. That puts our apoapsis actually very, very high. I'm going to completely flatten out our trajectory. It looks like we're clear, actually. So now, with our trajectory completely flat, I'm going to get some lateral velocity here. And we're going to push our apoapsis up to somewhere around 150 here. I don't know what our fuel situation is going to look like. That will be very, very interesting. We can see our apoapsis is already pretty high, but because we were so aggressive on going up, our lateral velocity is going to be rather low. So that's the trade-off that we're making here. We can definitely target a less aggressive curve if we want to. I just want to see how this feels. So our current apoapsis is about 110. We definitely need to continue to burn here. We got to get that lateral velocity up a lot more. Yeah, a whole lot more. I wonder what it would do to our launch costs if we dropped the SRBs and we made this be 8-side liquid boosters. That would also give us more fuel crossfeed, which would certainly be interesting. No doubt about that. So that's 150 kilometers, and we've got like 70 meters per second left. So that's understood. At this point, what would it take us to get into orbit? Okay, so an orbit would be about 500 meters per second. Obviously, that is not an efficient ascent profile, which isn't surprising in the slightest. So we could do what I said about swapping that over. That would be an interesting thing to try, actually, because that would allow us to have the fuel crossfeed, right? So we would get rid of everything out here, and we would duplicate this, although that's not duplicating the entire stack for some weird reason. We can just do this and then put this on here like that, and then have this guy in here, which is not... No, don't grab that. Which is not currently attaching to the... There is attaching to the interstage. Okay, so now what we would do is we would move this guy down a bit so that it's pretty much in line with the rest of these, like that. Then we would make sure that these interstages here have their fuel transfer turned to whatever the current fuel crossfeed is over here, which is set to normal. Okay, so something like that. So this is going to give us 1.38, so it's a lower starting thrust to weight. That's definitely noted. Okay, so we should have these, in theory, all detaching at the same time at this point. So we should combine together these interstages, and let's see what that feels like. So it's a little more expensive here, but a little less expensive here. I feel like it's largely a wash in terms of the cost. And let's see what that overall feels like. So let's put our heading at 120, and I'm going to actually set us at 70 degrees here, although we don't need the RCS on. And let's lift on off. So this is actually 1.28 thrust to weight. So we are actually losing a lot of efficiency to fighting gravity right now. We really want this to be more like 1.6. There are ways that we can achieve that. And of course, we don't have our fuel transfer actually happening properly here. We can go around like this, although it's going to be a little awkward at this point because it's not happening all simultaneously. Okay, something kind of like that. And that'll give us twice the fuel crossfeed, but also twice the amount of fuel, right? So that is fine for now. We can see our apoapsis is quite low still at around 5 kilometers. Our speed is very low, and that's because our thrust to weight only recently got to the point of what we should consider to be vaguely acceptable. So that's definitely noted. We have a lot of surface velocity here. Yeah, this is of course because our vertical velocity is quite low still. So the apoapsis is currently about 20 kilometers. I feel like this is a downgrade as of right now, but we'll see. So that's 30 kilometers. This is 40, so I'm going to drop us down to a pitch of 45 degrees at this time. We're definitely getting some halfway decent orbital velocity here. So that's 60 kilometers. I'm going to drop us down to a pitch of 15 degrees. We're working on that lateral speed here, but our altitude is still quite low at this point. So now is the part where we're experiencing large amounts of drag due to just how little vertical speed we had at the beginning there. But our apoapsis is currently decent. I'm going to put our pitch at 0 for now. That's 100 kilometers. Okay. And we're going to lose these side boosters shortly. Okay. So it'd be something like this, right? Surprisingly, we didn't have heat issues up here. That is quite surprising. But yeah, our thrust to weight was just very, very low there. So I don't feel like that was an overall upgrade. Although it definitely helped with the fuel crossfeed. There's no doubt about that. That was a significant assistance. But I do want to undo that and put this back here. Now, is our staging where it should be? Kind of. I want this to be here, and then I want the interstages to be here. Okay, that's back to where it should be. Okay, so we just need to get ourselves a decent ascent trajectory, right? So what I'm going to do is I'm just going to launch this at 120, and we're just going to do this way. Up we go. Much, much higher thrust to weight off the pad will get us through this lower atmosphere much more effectively. That's what these SRBs are good for. Okay, so we currently have an apoapsis of about 10 kilometers. I want to move us over to a 70-degree pitch at this time, and I want to start building up some lateral velocity. There we go. And now it's about 40 kilometers. I'm going to put us at 45, and we're going to hold there until this is burned out. Okay. Off go those SRBs. This one is attached still to something. It's being hauled along with us. I don't really know why, but whatever. Maybe... Okay, there, it got destroyed. Cool. So we're going to set our pitch to 15 degrees. Now, we didn't do the fuel transfer here, and you can see that's definitely a bit problematic. So let's get that fuel transfer going. And we're just holding here at 15 degrees for right now. The heading just changed to 123. I want it at 120. There we go. And do that. Okay. So we have an apoapsis of 110 right now. And this time we have a fair amount of additional lateral velocity. So this is 120. We have a lot of fuel left at this point, actually. 130. 140. I'm going to drop us down to a 5-degree pitch. And there's 150. Cutting engines, and we're going to let this fuel continue to transfer over. So engines are cut at this point, and we want to plan the burn at the apoapsis, and we want to get this guy into orbit. Okay, this is why we had a lot of fuel left. It's going to take a lot of lateral velocity to get us into orbit here. Okay, we just didn't build up as much lateral speed as I would have liked, but let's go ahead and run this. So we were able to transfer most of that fuel over. And we're going to light up, and these engines will burn out fairly soon. We're going to ditch those, of course. Okay. They're burnt out, although they burnt out slightly awkwardly. Cool. So we can see we've got about 1 kilometer per second left here, and we're just going to accelerate this right on up. We're at 2,300 orbital velocity for right now. So this looks quasi-decent at this point. We've still got a good amount of fuel left here. 700 meters per second left, which is probably pretty close to what we need. 600 there, 500 here. Yeah, that's very, very close. I think we might be good on this ascent. Would have been better if I had started the transfer on the ground. No doubt about that. That transfer speed is rough. No doubt about that. Okay, so these engines are burnt out now. And let's go with our vacuum engines. We're at 3,300 meters per second right now, so you can see that we're actually in orbit. We're in orbit right now. We can see that if we go in here, we can see our periapsis is up above the atmosphere. So we don't actually need to circularize this, but it's still a kind of useful thing to do. We just need about 35 meters per second. No, I'm content with this. We're going to stick with this one. Beautiful. So that seems magnificent. I mean, it's going to take 2 minutes to burn this. This is incredibly low thrust to weight, but this is because this thing is just so heavy. This module is incredibly heavy, and $100 million is not enough. I can tell you that right now. But we managed to do it at only, you know, triple the budget. It's fine. We'll make money on the next one. I'm quite confident that we'll be able to make money on the next one. Maybe not make back this money, but we'll make something. Okay, so we should be done with this burn very shortly here. We've got a little while left. I'm actually going to cut the engines here, and we're going to get rid of this. I would like to, at this point, come back around unless... If we were to burn here, hypothetically, would that be close? It isn't showing us projections. There we go. 56 kilometers apart, huh? That's actually not bad. So like 6 kilometers apart, 166 meters per second. I mean, it's going to take us a long time to burn that 166 meters per second, but I don't mind that, actually. We can tune this down and have this approach info be about 1 kilometer apart. Would be the ideal, but we can tune this in. We're going to have long burns here. Like, this alone is going to be a 4.5 minute burn, right? So that's definitely a concern. Our battery's still chilling at 100%, so I think that we should just do this. We don't need to circularize. We don't need to do an inclination change. We can just come in like this. Be 3 kilometers apart. I like it. That saves us a lot of time. Now, this is going to be a very long burn, and yeah, 4.3 minutes here. So that's understood. We have medium accuracy on the burn because it's so low thrust to weight, but I'm really not too concerned about that. I'm really, really not. At this point, it should be relatively fine. So it's like 100 meters per second, another 100 meters per second there. We've got over 1 kilometer per second in this. So our thrust to weight will increase a little bit, but it is not going to go up very much at all. So yeah, I'm reasonably content with this as of right now. Let's just push this on up and get ourselves into a position where we can do the docking probably next episode at this point, because these maneuvers are going to be slow. But with this payload being like 500 tons, I'm not surprised about that. We are about 50% done. This just ticked up to high accuracy. Interesting. I didn't expect that to change. That's good to know. Now, as you can see here, our inclination is a little bit off, and fixing our inclination will be part of bringing this together, but I'm not concerned about that. We will do that as part of our Get Closer burns, most likely, because this is definitely a decent launch timing, shockingly enough. Pure luck there, of course. But we're now about 75% through this burn. And that looks great. I mean, we're still going to be 3 kilometers apart, but we definitely are going to want to dial that back. We want to cut back on this 156 meters per second. No doubt about that. And then we're just going to do a Get Closer burn. So I'm thinking that what we're going to do is probably do a burn sometime around like here. Let's see. I need to think about that, because if we did our burn here, it'll do half the burn on this side and half the burn on this side, which isn't necessarily what I want. So I'm thinking we do most of the burn here, right? Or at least start the burn sometime around there. Okay, so that's retrograde. We kind of need to go, well, we would want to go target prograde. So that's, or rather target retrograde. So that's fine. Let's open up the nav ball and let's go into, well, we want to be in target mode. There we go. And let's check here. We want to be at velocity retrograde. There we go. So we're just going to position ourselves around here. We're kind of tumbling for the moment, and this isn't surprising at all, because we have a tiny little reaction wheel here and a whole lot of weight. So that is not shocking. We could use some monoprop for this, in theory. That is definitely an option. But what I want to do instead is I just want to get to position here. And there we go. We'll just lock it into position like that. So we'll freeze the physics, and that will help us a little bit anyway. Okay, so now as we approach up here, I'm going to warp to about, well, 156 meters per second is how long of a burn? That is question number 1. So 156 meters per second. Well, yeah, 156. That is a 7.5 minute burn. And that just goes to show how low thrust to weight we are. Okay, so 7.5 minutes means that we would need to start this burn at about 6.5 minutes or so, here. Okay, so we'll go ahead and warp there. And we want to tune down our relative velocity. So I'm going to begin our burn out over this direction. There we go. And you can see that this is tuning down. But this is going to push out further and buy us more time. So you can see I moved slightly off of the target retrograde here. I'm pushing these two nodes together. So we're probably going to have to turn up over like here or so. And you can see now that our target position is close enough. At this point, what I want to do is not necessarily be pushing these together anymore. Yeah, this is now going to be pushing away, but that's just because we overshot this a little bit. Yeah, this is fine for the moment. So we're going to need to just drop our relative speed, and I'm completely fine with this number going up. It'll go back down again if we head back over this way. So we'll just keep burning here for a while, and we can see our relative speed is going down, but it's going down quite slowly. I'm going to take this up into 2x speed here. And I'm just going to take us slightly off of the node here. There we go. Cool. And you can see that our approach info is changing. It's going up quite a lot. And I would like to counteract that a little bit. I'm actually surprised that it's still going up here. Okay. That is surprising. Let's burn anti-target and see what that does. Because we need to be burning retrograde here. So we actually need to be burning, like, out here, then? No, this is probably due to our lack of inclination alignment. Okay. Well, for now, what I'm most interested in is just dropping our relative speed. So we're down to about 96 meters per second, and for the moment, that's reasonably fine. I'm just going to lock our velocity to retrograde here, and yeah. So what we probably need to do is burn a little pro-target, but what I would really like to see is a situation where we are relatively parallel to the target and can burn towards it. But for the moment, we can lock velocity to target here and dial this in a little bit. This is going to increase our relative speed, which is the unfortunate part here. So we would want to come down over here, I think. Yeah, and you can see that the meters per second is increasing. So what we really want to be is burning down over like this way and twisting our orbit around here to dial this in and hopefully be simultaneously. So this is going to be like a radial-ish burn, right? Okay. Something kind of like this-ish. Unfortunately, yeah, this is going down in terms of relative velocity. We want to bring that closest approach down, so burning about here while simultaneously dropping our relative speed. Although it's not dropping our relative speed very much. But this is down to around 10 kilometers now and 93 meters per second. So we've got 4.2 minutes until we arrive there. That should be reasonably fine. I'm really not too concerned about that. Okay, so we are losing a little bit of efficiency on our speed dropping. Let's just bring this in over to about here. There we go. Or rather, on our approach dropping. And I'm wondering what our situation is right now as far as our relative velocity. I wish we had a little bit more precision than just 1 meter per second. That would be nice. Alas, we do not. Seems like our relative speed is kind of fine, but I want to put us onto velocity retrograde now. So we're going to head down over this direction, and you can see our closest approach info is going down over here as well. So this is absolutely fine. We'll just position ourselves about here or so and continue to drop our relative speed as well as reduce our closest approach info. So that'll be fine, but we definitely need to drop our relative speed by quite a lot. So we're down to 78 meters per second. We can see we're 2.5 minutes away right now. Question is that going up or down? And I want to move us up to about here at this point. 2.4 minutes. Okay, that's going down. So that is noted. We're not pushing that further out at this time. But we do definitely need to drop down our overall relative speed. So I'm just continuing to tweak our overall positioning here. Dialing in that approach info and this relative speed. So that's down to about 50 meters per second at this point, and I just want to put us right about here for right now. There we go. This is back up to 2.5 minutes now. So at this point, we're pushing this a little bit too far, and we should come a little closer to the velocity retrograde. Actually, it's kind of the other way around, isn't it? It's okay. So we're only about 30 meters per second separating us now, and this closest approach info is definitely getting a lot better. We're down to 2.4 kilometers, and I'm just watching the movement of this node here. I want to move to about here, just slightly steering it differently. Okay, so these nodes are basically together as of now. It definitely could use a little bit in terms of steering here, but that is relatively fine for now. We could do a little bit of correction out over this way, ever so slightly. But for now, we're in a pretty good spot. We can see we're about 6 minutes away, so that looks good. For now, it is time to put a cut in here, so I'm going to go ahead and do that, and next episode, we're going to arrive at the spaceport and do our docking procedure. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and a very special thank you to all of the channel members for making this video possible, including ALS Gamer, Atala, Andy McGar, Ali Lee, Dark Horse, Xenocyte, Hiro Marutsu, Upper Cumberland Gamers, Nick Smarty, Dimitri H, Punching the Microphone, The Lounge STL, and all the rest. And of course, you. Thank you for watching. If you'd like to support the channel, you can click the join button down below the video, and as always, I will see you all next time.